Hello, I'm Hugh, and I'm here today to talk to you about some generative percussion pieces I've created in Chuck. Chuck is a programming language that is very musically oriented and is based on Java. So those skilled in Java will have no trouble transferring to this kind of language. You have a lot of things that are specifically designed for producing sound and taking sound out and timing sound very specifically. For example, you've got these DAC things, and DAC is digital to analog converter. So it takes digital stuff and transfers it to analog and then pushes it out your speakers. You get the opposite, the ADC as well, analog digital converter, which goes the other way if you've got input from a mic or something. Anyway, so this piece is based on this class that I've created, which I've called a loop gen, or the loop generator. So what this class does is it produces all the sounds. It tells you what sounds to do, where to put them. So this is all the sound rubbish there, and this is where to send them. So we got some hi-hats going out left and right and things like that. And this is largely what to do when we receive certain parameters when calling the function or the play function inside this. So this is some of the timed stuff that Chuck is very good at dealing with. So if I'm to play this now, I'll just give a very quick demo. So I'll add the shred, and then this one plays the shred, and I'll show you some more of that code in a sec. So if I just play very quickly. Okay, so I've removed that now. So what this is doing, this function is not being used in this, so we won't discuss this. So this is activating this class. So this is the loop gen, and I've called it this all your bass. So every time I activate this and call this function play, I chuck in all of these different parameters, and it needs all of these parameters, which are 7 instrument parameters, these last 7 here, and these first 3 which are to do with the music in general. So in this class here, this is taking in these parameters, and all of these parameters are to do with this here. So I'll explain what each one is. So the first one is the number of beats in a bar. Sorry, I haven't said that each one of these is a single bar within this piece. And what is going to be happening is I've coded a bunch of these bars and told the general parameters for those bars. That is what this function, this loop gen function does, or this loop gen class does. So I'm telling it general parameters for each bar. So this is where I write my structure. And as I've called this a sonata, it's going to have the general sonata form. So we've got an intro, we've got a first subject, which each bar takes up all of these parameters here. And then we've got a little bridge and a second subject, and then a smaller bridge and a development, and then a recap. Okay, so we've got the general sonata form there. So how am I creating this kind of sonata form? Well, what I'm doing is I'm keeping some of the parameters the same each time. So for example, we've got 3s, 1s and 60s, 12, 2s and 180s. Some of these are all very similar down here, and I'll go into what these are in a sec. And then when we come into the second subject, you can see this number is vastly different. So the 60 and 180s, 60 is a third of 180, those numbers are related. And here, 50 and 100, those numbers are related as well, but in a different way. So 60 is 1/3 of 180, but 100 is 2/3 of 150. So they're related in different ways, but also similarly. So now if I go into saying what each one of these exact parameters are. So I mentioned before, these first 3 are to do with the general music, and then these are specifics. So the first one is the number of beats in a bar. The second one is the number of times the bar will iterate. and the third one is the tempo of that bar, or the tempo of one beat within that bar. So you can see this bar will play a 3-beat, it will play 3 beats, it will play it through once, and it will play those beats at 60 beats per minute. This second one, just to contrast, will also do 3 beats. It will play them through twice, and it will do them at that same 60 tempo. This one will only play once, and it will only do 1 beat, and this one will do 2 beats, and will only play them once as well. So if I play that first introduction again, there we go. So now if I move on to this, to saying what this is. So each of these represents an instrument. So this one is the hi-hat. This one is the open hi-hat. This one is the, if I can move down this, the kick. Then the next one is the snare. The next one is the tom-tom. The next one is the cowbell. And the last one is the maracas. So each one of these is saying how many chances does any one of these instruments have to generate a single time during this bar. Now that seems quite complicated, but if I break it down, so in 3 beats, the hi-hat and the open hi-hat have 32 chances to generate on any one of those beats. So therefore, it's extremely likely that we'll get a note on all of those first 3 beats. And if I play this, we got it. We got a one on every beat. Again we did. And again we did. So it's extremely likely that that will happen. But there is a chance, a very small chance, that it won't do that. That we won't get those 3 beats on every play. So that's where the interest in this music comes. So some of these are coded to be very close to always playing, and some of them are coded with a lot more variety within them. And that is how I've basically made up this piece. So if I'm just to play a little bit more through these, and if you watch here, you can see which of these we're in. So it'll say it prints the location or which bar we're in up here. So you can follow that along with which pattern we're in as well. So I'm just going to start now. So you could hear there at the end the second subject just starting, and you can see that the tones in that are very different. I use different instruments more often. So lots of this first section is around the first 4 instruments, and the second section uses more of the last 3, and occasionally those bass drums and the snares as well. There's also this added feature of the cowbell, in that it will actually generate a slightly randomized pitch as well, which adds a bit to the later sections and makes it a bit more interesting. So that was drum gen. I also have one which is based on the exact same class, but slightly different. So this one is called pulse gen and pulse play. So pulse gen is almost exactly the same, uses the same kind of bar mechanics. So I'm building up the same bars in the same way that I was in the last piece. But this time, the actual instruments used are generated as well. So this is all mathematical oscillators like saw waves, sine waves, tri-waves, pulse waves, and square waves. And you can see how they're arranged there as well, in left and right. And also their frequencies are generated as well. So if I am to just load this sound in and play it very briefly. Okay, so you hear the introduction, which is similarly built up from before. We got 4 bars again, you can see. This time the tempos are slightly different and they're in more of this pattern. And you can see that I'm using the higher ends of the spectrum here for this bit. So what's interesting in comparison to the last piece is those instruments were directly pre-designed, pre-composed. There was almost no randomness into them, apart from the cowbell, which was. So in pulse gen, all of those pulses are different. So if I play this again now, you'll hear that different notes have been generated. Okay, so you heard there various, almost the same kind of rhythmic patterns coming out, but different note patterns from that. So then that became a feature for how I can vary the different sections up. Because we have, in this piece, I used the exact same object, calling this class again each time and creating a new version of the same class, because it didn't make a difference if I changed, whereas this time it now changes. So now we've got one instance of the object, and now we've got a second instance of the object, so that it can generate 2 different types of sounds each time. And that's why that was useful to me. So on a full playthrough of this, you get a few different types of generated sounds. And that's it really for the general makeup of these pieces. So the only further thing to talk about is really how do these differ from a standard static sonata. So the general makeup of these is exactly sonata form. So the structure is set, the bar is set. You'll find if I play one version of this and then a second version of this, they'll last for the exact same static amount of time. I believe this one's something like 2 minutes and 43, something like that for this whole piece. So how does that differ? Well, it differs in a way that every single bar is not the same. It's not exactly the same. So I couldn't necessarily write an accurate score of this. But what I can do is tell you generally these are the chances of you hearing this note or this pitch or this pattern within this this particular bar. So that's what gives this the generative quality and the generative variety about it that you don't necessarily see in a typical sonata. So that is drum gen and pulse gen. I hope you've enjoyed listening, and I hope you understand a little bit more about the makeup of these pieces, and I hope you enjoyed.